Hello class, welcome. We're going to learn about bisectors in triangles, chapter 5, section 2. We're going to use properties of perpendicular bisectors and angle bisectors. So take a look at TU, which is a perpendicular bisector of RS. And just to review, the word perpendicular means we'll have a right angle here, and then bisector of the segment RS, so that means RM is congruent with MS, which is shown by the tick marks right here and here. So then what can we say about T, V, and U? Well, you're going to learn a theorem today that will explain, and you could kind of guess, that V is the same distance from R as it is with S. And then T, really any point, you'll see T and U, we'll say T. This is the same distance to S. So if you could picture a length there as it is to R. Any point on that will be the same distance, which brings us to theorem 5-2, perpendicular bisector theorem. It states just that. So if you look at the points in yellow and blue, any point on the perpendicular bisector of a segment, it is equidistant, which means equal distance to the endpoint of the segment. Right here and right here. And then you have a point in yellow, which is the same thing there. Next, on to theorem 5-3. It's the converse of the theorem, so pretty simple. If a point is equidistant to the endpoints of a segment, like we have here in yellow, and if that's the same distance to this part in yellow, then, well, it has to be on the perpendicular bisector of a segment. So again, converse, you're just flipping the statements, nothing too difficult. Alright, then we have the angle bisector theorem. We'll go through this really quickly. Basically, if a point right here is on the angle bisector, if there were curves here representing that this is the angle bisector, then it is equidistant from the sides. So this part in yellow is the same distance as this part in yellow. And when you draw this, you want to go at a 90-degree angle to the side. So there should be a 90-degree angle there. You just want to go directly to the side, and it'll be equal distance. And then you could guess the converse will mean that if the... Should I just keep talking like this? Maybe I'll switch it up. If a point is in the interior of an angle that's equidistant from the side, so if this is equal distance, then that point has to be on this angle bisector right here. Alright, let's see. What? Why is Kanye West playing? Uh-oh. Good song though. Let this ride out for a little bit. Alright, anyway, sorry about that. Gotta love Kanye West. But CD is the perpendicular bisector of AB. So CD is the perpendicular bisector of AB. Well, we're going to use the perpendicular bisector theorem to say this distance of 5 is also equal to this distance, CA, which is what we're trying to find here, which will also be 5. And then you'll use a similar thing. Point D is on the perpendicular bisector here. So that's going to be an equal distance to A as it is to B. So DB will be 6. Very good. Alright, next I want you guys to start to think about this. We're using the angle bisector theorem. So you see an angle bisector here. This is the angle bisector right here. And we know these two will be equal distances from each other. So what would you do? Let's see, 2x plus 5 and 7x minus 35. If they're equal, how about you set them equal to each other? How about that? And you'd go through, solve for x, nothing too difficult. Okay, then a little problem here. According to the diagram, how far is K from ray EH? So K is right here. How far is it from EH, this ray? Well, it shows you there it's 10. Not too bad. Now let's go to how far is it. Sorry, what can you conclude about ray EK here? Well, it's an angle bisector, you see by the two curves there. And also its equal distance from point D with point H, which is going to help us in the next thing, find the value of x. Sorry, not that thing, not yet. So let's see. These two angles are equal, so can we set 2x equal to x plus 20? Of course, if they're equal, set them equal. And you solve for that. Let me go back. You solve for that, you'll get x equals 20. You can do that on your paper at home if you'd like. That might help. And then lastly, we're trying to find measure of DEH. So DEH. That's the whole angle. Well, x equals 20, so 2x, that's 2 times 20 is 40. And both of these angles together will add 40, and 40 will add to 80. So that's it for today. Thank you for listening, and thank you, Kanye West.